answer. Now, there still is some thinking involved, but for the most part, if you just kind of follow the steps, the formula does the work for you. So let's try, and I'm going to say we're going to try another problem that has this repeated or two parts feel to it. So the last example that I did with you, where you just kind of like, whew, okay, I'm glad that's done. But we want to be able to do a problem that has a repeated or basically two steps of parts. Now you'll learn, hopefully after this problem, how you know already that this guy is going to require two steps. But honestly, at this point, if you're still a little wet under the ears, you basically can just do the lipid test. You can look at this and you can say, do I have an L? Give me an I. Give me a P. We have a P. We have a power function. Okay. Of course, it's not always that U is the power, but according to the lipid test for this problem, it is. Now, that means the rest of the problem is dV. The rest of the problem is dV. So we have U, dV. We basically have our two parts that are multiplied together. All right, so we're kind of making this little box of calculus variables. Fun stuff here. We should rename it sort of like the calculus cookie jar. You basically reach in here and you have all your cookies that you need. Like the derivative of U. That's a nice one. That's like a good chocolate chip. And then you go back here and you find your antiderivative. Okay, now be careful. The antiderivative e to the negative x is e to the negative x divided by k. So divided by k basically is dividing by -1, which throws a negative sign in front of that answer. I'm not sure why that looks like it's an exponent. It's just negative e to the negative x. All right, so we've got our calculus cookie jar. Okay. Get to know the formula. Make sure I'm not the only one saying it. Sometimes saying it to yourself, saying it out loud, but it's uv minus the integral of v du. uv, that's just x squared and negative e to the negative x. Remember how we changed the order? It's just best if you put the numbers in the order where the power function comes first. Minus the integral of v du. Minus the integral of v du. Again, changing the order a little bit. Putting the negative sign in front of the whole thing. But I basically multiplied these two cookies. Okay, and you saw me do at least one problem, but it's very common where you end up with negatives everywhere. Yes, you're allowed to just change this to a plus plus. Always do algebra before calculus. Now, I want you to come to the realization that that integral requires another calculus cookie jar. It requires another parts. It requires another analysis of U and dV. Basically, you have to do the lipid test again. Listen, that's because we got two functions. 2x is a function. E to the negative x is a function. If you have two functions, you gotta use our fancy schmancy parts formula. Okay, so we do another lipid test. U equals the power function. dV equals e to the negative x. Maybe you kind of feel like that you did this before, but you didn't, because the derivative of 2x now slides down to just 2. And well, your v is the same thing. Now, when you guys get good at this, you're going to realize, okay, I see what's going on here. My derivative keeps getting smaller. In fact, that's exactly how derivatives work. If you look for a second here before you do the rest of the problem, if you look, x squared was my original u, 2x is my derivative. Well, that's where I pick it up with this 2x, and then my next derivative is 2. I'm going to be showing you guys a shortcut that allows you to think about what I just pointed at over here to a little more quickly get an answer. That is that the derivative keeps getting smaller. But that's actually what derivatives do based on the rule, based on the power rule. Just like I did in the video, I assume that you know what I'm talking about. We're going to try to connect this box, that is this integral, with the next list of formula. So to do that integral, I have to do the formula again. Always good practice. That's why I'm just pausing if you want to try it. UV is basically multiplying these top cookies together minus the integral of v du. Okay, we usually put the negative sign first. We'll put the number 2 first, but that's the integral of v du. Okay, still can do a little bit of plus or positive, you might as well, but really it's now this integral of 2e to the negative x. Let's get it in white now. 2e to the negative x. When you look at that, that's actually an integral that you could have solved 2 weeks ago. Nothing's easy though, but I do want to say that's a basic integral. It's basic because it's just one function. And that one function can be solved with just a rule. So when I do the integral of this, I carry down the coefficient of 2. I do the integral of e to the negative x, which is like the same thing. And then, of course, you divide by k, which is why we're going to end up with a negative sign in front of this. So the integral is finally complete. But don't lose track of the rest of your formula. The rest of your formula is still part of this final answer. So I have negative x squared e to the negative x minus 2x e to the negative x minus 2 e to the negative x plus c. Now, what we just did here is necessary for understanding the parts method. However, there is a shortcut to it. I want to be clear, though, that the shortcut only works in certain cases. Before I show you the shortcut, do you seriously have something that you want to ask about? Maybe it was from yesterday, maybe it's from today. Okay, again, I just want to be clear that although the shortcut, you're going to say, oh my gosh, that makes that a lot easier. We still have to know how to do this formula. Okay, we'll do some more problems today that you need the formula for. But it is time to reveal this little secret. It's called the tabular method. The tabular method is a way to do parts when u equals a power. Again, you can only use the tabular method when u equals a power function. But it is kind of a quick way to take my cookie jar here and to turn it into a tabulation, which basically ends up being 2 columns. Sometimes people are like, what do you mean tabulating? Tabulating is kind of like when you're just calculating individual parts, which end up showing up in 2 columns. These 2 parts, these 2 columns, still end up being my u and dv. But again, it makes for a really slick way to find this answer. So we'll still use the Lipid test on u. I'm kind of going back to the original problem. The Lipid test, well, is still going to say that u equals x squared. That's actually what gets put right here. The Lipid test says that dv still ends up being e to the negative x. Now, what ends up being placed in these two columns? Take a little look with me. It's kind of what I was showing you one time already. It's realizing what happens with u. U just becomes, well, it becomes its derivative, 2x. And then, well, it becomes its next derivative, 2. And as you'll see, the next derivative would be 0. So basically, what ends up in this column is u and all of its derivatives. If you want to write that down, I'm just kind of going a little more slowly, or just listen to it again. It's u and all of its derivatives. And as you can probably guess, over here on the other side, we end up with dv and all of its antiderivatives, just like I did over in sort of this box of variables. So I do the antiderivative of e to the negative x. Of course, it's the same thing divided by k. But then you do the antiderivative of the next one. Now be careful here. There's a little dancing around with negative signs, so I'm going to end up with back to e to the negative x. And then back to negative e to the negative x. Now you can almost look anywhere you want. You can look at the answer. You can look back at some of the steps. But do you realize that this formula always has you do something with these variables? Connect them, multiply them. There's always this multiplying that's occurring. But this is kind of what makes the tabular method so cool. The multiplying, the connecting always occurs, in this case, on a diagonal. Those arrows represent multiplying. And then there's one more thing. It's that darn subtraction sign up there, okay, which basically creates a little pattern that can be shown like that. It always starts with a plus, and then it just oscillates back and forth, plus, minus, plus, minus. So, well, I assume that you realize we were doing the same problem, but that means that the integral of x squared to e to the negative x is going to equal simply now putting all this together. Positive x squared times negative e to the negative x. Okay, plus, now technically I'm going to change that plus sign to a minus sign because it's negative 2x times e to the negative x. So I'm actually going to change that to a minus sign. But you attach these terms with addition. But again, here, 2 times negative e to the negative x is actually a subtraction. All right, and of course, we just wrote down the same thing. Tabular method only works if u is a power, because what's really happening is that u is disintegrating, eventually deriving to become 0. We don't have enough time to talk about how that's not going to work for a regular problem. It just doesn't make sense, especially if you think about yesterday's lesson where we had a few problems that were a little more regular. But why don't you try one? Why don't you try one that you should say is tabular? Okay, now eventually, if not already, you would look at that and say, okay, I can tabulate that, not just because the teacher said so, but because you is a power. If you think about the lipid test, you're going to choose u to be x to the fourth. How to go kind of bouncing back and forth between sine and cosine. Maybe you just want to double check that you did the antiderivatives correctly. The antiderivative of sine is actually opposite cosine. The antiderivative of opposite cosine is still opposite sine. It's all right if you want to ask something. Again, these are just antiderivatives of sine and cosine, or with the opposites. So we have the plus minus pattern. Make sure you're always connecting the variables through a diagonal multiplication. And you have a really long answer. It's like the stairway to heaven. Got all these steps, and at the top is this lovely integral. I'm not sure, was it Led Zeppelin sang that? Stairway to Heaven? I don't think that's what they were singing about, but that's what I'm thinking. What are you thinking? Crazy stuff, okay? It's really the product rule backwards. It's interesting. If you would do the derivative of each one of these stairs, you actually would end up just back to this, because lots of stuff would cancel out. Okay, but really when you use the parts method, you're reversing the product rule. All right, when you guys come back, we still have a couple more integrals that won't fit into this tabular method. Okay, but we'll save that till you return.